The service name is a human-readable description of it's a unique identifier for your machine. So it can be up to 63 characters long. Oftentimes, you'll see like a hexadecimal string. Sometimes you'll actually see the machine name. All characters are allowed. All UTF-8 characters are allowed. And this is what uniquely identifies your name as a service on the network. The service type, which is the second parameter in the service address, is a 14-character service name, which describes the type of service, and it's a string that you choose. And there's some that are already chosen. For example, the iTunes sharing is underscore DAAP, underscore DAP. And there are a few others that it uses. But what you want to do is you want to find a service name that is unique to your application. So if there's 10 versions of your application running, and each of them advertises a service, they'll all have the same service type. But they'll each have a different service name. And the last piece in the address here is the transport protocol name. So the transport protocol name can either be TCP or UDP. There are no other choices. So yeah. Here's an example. So this is an example of a printer. So a printer is advertising itself using the Internet Printing Protocol. So its name is Canon MP780. Its service type is _IPP, which is a pre-agreed upon service type. And the protocol and domain are _TCP for the protocol, and domain is .local. Your domain can actually be, I don't think I get into this in the slides, but your domain doesn't have to be local. You can actually advertise on a greater scale if you have something called a Bonjour DNS server. So you can have a service that's advertising itself to the world, as long as all the different pieces, all the different services that you're trying to connect to know about that DNS server. So anyway, the easy case is it's local, and I'll show you an example of that as well. So publishing a service is very easy. NSNet service is the class that wraps the Bonjour mechanism. You create one by saying init with domain, and you can pass in a string here. If you leave it null, it's going to assume, if you leave an empty string, it's going to assume that it's local. You could also pass in local. You could also pass in the DNS server there. But for now, we'll leave it empty. The type is _IPP._TCP. So this is your service name and protocol. Name is the name of your device that uniquely identifies you. And in the case where you're trying to publish a net service, which means you're trying to advertise a service, you pass in a port as well. And the port is whatever port you're using for networking for your service. You would get this by, if you have an HTTP protocol as the backend, you start up an HTTP server, and that HTTP server will have a port for communication. That's the port that you use here. Again, leaving the domain name blank is local. And leaving the name blank, if you pass in an empty string for name here, what you're going to get automatically is it's going to ask the device for its name. And the device's name is whatever the user configured in iTunes when they set up their device. So by default, my phone would be alphone.local. Publishing a service, right? So what we created it in the last slide. The first thing you're going to want to do is set your class up as the delegate for the net service. And the delegate's going to give you a bunch of callbacks. We'll look at those in a moment. But then it's pretty much it. You call publish. And publish starts it up. There are some tools on the web. Actually, there's a great one called Bonjour Browser if you search for, if you want to debug this stuff. As soon as you call publish, as long as you've passed in valid parameters to the init call, that service will now be live on your network, and you can find it with one of these tools. And of course, tearing down, you want to clear your delegate, as we always talk about, right? If you're deallocating yourself, you make sure you're no longer the delegate of any objects. You call stop. Stop says stop publishing. Then you release it and deallocate. Here are some of the delegate methods that you can get back. So the first thing, actually, conflict resolution. Let's say you have a printer, Canon, whatever that was, MP380. If there's already a Canon MP380 on the network, Bonjour will go ahead and, unless you explicitly tell it not to via a property, Bonjour will go ahead and rename that service to something unique. So it could be Canon MP380-1, Canon MP380-2, so there's 3 printers on the network. So that's pretty useful. It just guarantees that your service can be uniquely accessed. And here are some of the delegate methods below. So the first thing is you can get, you'll get called back when the publish is about to begin. You get called back if the publish was successful, and you get called back if there was a problem. And of course, there's as usual, there's an error dict there, or it's often an error. In this case, it's a dictionary, and you can find out more specifics about what actually went wrong. All right, finding a service. So you've gone through, you have one device that's gone ahead and advertised itself, it's published itself to the network. Now you have some other device on the network that wants to find instances of that service to connect to. So for example, I like to go back to remote. With iTunes DJ, right? There's a feature you can turn on in iTunes that basically advertises itself so that any client can come in and request songs for playback. And then any remote, when you launch it up, it goes and says, hey, are there any iTunes DJ services available? And it gives you a list of them, and you pick from them, and then all of a sudden you're connected and you can start requesting songs. That discovery is what we're talking about now. So the ability for the remote to find any iTunes DJ libraries, this is the mechanism that it does that. So the application registers. So when you create a service, you register the service name. But the discovery of the service happens with NSNet service as well. And then you can go and resolve a service to get the actual IP address for doing real communication. One thing I want to note here is that advertising and publishing of a service doesn't actually do the communication. It's only a way of handling the translation and discovery of services to IP addresses. So I'll take you through an example of how this works. And then we'll talk about NS streams, which will help you actually transfer the data back and forth. So when you're looking for services, there's another class called NSNet Service Browser that you create, you instantiate, alloc init, you set yourself up as the delegate, and then you search for services of type, and you pass in the type string. It also takes a domain parameter. You probably guessed an empty string just goes to local, whatever the default domain is. But you can specify something that's bigger, so you can search for, you can search a greater scope. So you start the search by calling search for services of type, and then you'll get a few callbacks here to let you know what it's done. The browsing is all asynchronous, so none of this is going to block main thread. All of this is going to give you a callback when something actually comes up. So let's say I start browsing for services. Of course, I'll get notified when the search is going to begin. I'll get notified when the search is going to end or has already ended. I'll get notified if there's an error. But there are two interesting ones here down at the bottom. The first is did find service and did remove service. So let's say I have, go back to the remote example. I launch remote on an iPhone, and I'm looking for iTunes DJs. Now, somebody on my same network launches iTunes. I can be looking at my remote at that time, and as long as the browse is still happening, which you can let it go indefinitely, then when that iTunes launches, you'll automatically get notified, did find service. You can present a UI to the user with the name of the service, the type, any other information, and it'll be there for me to pick. If the user then goes and quits iTunes, then we'll get a did remove service, and then you can take it out of your UI or disconnect the user because they can't talk to them anymore. So that's your methods for those are your methods for discovery of services. Once you have a service, you don't have the IP address, which means it's not sufficient to talk to that device yet. You only know that that service exists. What you need to do next is you need to resolve the service. And resolving the service is actually it's the mechanism by which Bonjour will translate